In this video, let us understand this formula, which is a freshwater allowance in millimeter is equal to displacement in tons. This is summer displacement divided by 4 into TPC, which is tons per a centimeter. Now let's have the ship, and we are looking the ship in the transverse direction. As the ship is in salt water, this is water line W and L, and this is the underwater volume. Let me mark this. This is underwater volume, and it is denoted by capital letter V. Now as the ship goes to freshwater, ship will sink further, which will increase the underwater volume. So now the ship is in freshwater. This would have increased the underwater volume this way by amount small v. We know that the mass is equal to volume into density, which comes from this formula. Density is equal to mass over volume. So mass is equal to volume into density. Well, mass of salt water displaced is going to be 1.025. that is the relative density. Instead of this density, we can use the relative density. Relative density of salt water, which is 1.025 into capital V, which is the volume of salt water displaced. Similarly, when the vessel is in freshwater, the volume is small v plus capital V. Look at this. When the ship is in fresh water, the total underwater volume is small v plus capital V. So the mass of a fresh water displaced is going to be the density of fresh water, or relative density of fresh water, which is 1 plus V plus V, that is capital V and small v. Well, both are same. Why? Because we have not loaded anything or discharged anything, so both are same. So this means 1.025 capital V is equal to capital V plus small v. Well, we can simplify this further, which gives small v is equal to capital V divided by 40. Why? Because 1 by 40 is equal to 0.025. We can check with calculator as well. Now we'll multiply both the side with 1.025. So we get this relationship. Small v multiplied by 1.025 is equal to capital V into 1.025. We have multiplied both sides with 1.025. So I get a very unique relationship. Suppose small w was mass of salt water in volume small v, and capital W was mass of salt water in volume V. So with the relationship D is equal to M by V, so M is equal to V into D. So for V into 1.025, that is mass of salt water in volume V, I write small w. Similarly, for mass of salt water in volume V, that is capital V, we get this capital W. So the relationship is small w divided by capital W divided by 40. Now we'll use the application of a TPC. While TPC is tons required to change the ship's draft by 1 centimeter. So in case of cargo to load, we have this relationship that cargo to load is a mean sinkage in centimeter. This is important. And the TPC. Well, here we will see that the sinkage is nothing but the freshwater allowance, because that is the increase in draft when the ship goes from salt water to fresh water. So that the freshwater allowance is increase in draft when the ship goes from salt water to fresh water. So this is our freshwater allowance. Well, we need to have this allowance in centimeters, so I multiply this by 1/10. So this is nothing but a sinkage. And this is TPC. Well, this will give me cargo to load. However, we have just concluded that small w is equal to capital W divided by 40. So instead of this, I can write like this. This small w is freshwater allowance into TPC divided by 10. I write the full equation like this, is equal to W by 40. So freshwater allowance is, I get the TPC this side. So freshwater allowance is W divided by 4 into TPC, where W is summer displacement. Summer displacement, which means that vessel is loaded up to summer load line mark in a salt water, and the TPC is tons per a centimeter. That is the immersion, which is also for salt water.